You know what I think it's time for? I think it's time for the binary numbers video. I've talked about this a lot with my friends in private. I've said so often, there needs to be a video that explains binary numbers better than anything else that there is out there on the internet. And yet I put it off because I didn't know how to not make it dry and boring. And you know what? Today I decided, screw it. I would like you to imagine you're working with a German. And you know your numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then you go up to 10. That's when you start using the next digit. But this German guy, bless him, he knows English pretty well, but he can't help but confuse the word 9 with the German word for no. So let's think about what would happen if we decided to just not use 9.
None.
Count up to 8, and then 10. What would the implications of that be? There's actually no rule stopping us from doing that, other than social pressure. What you end up doing is creating base 9 numbers and arithmetic. What you realize is the rule for what increments the tens place, or the digits of the order of magnitude higher than the one you're working with is, what makes that tick up is when you can't put a value large enough in the smaller digits. You see, we count from 9 to 10 because we don't have a single digit which represents 10 or more. That is unless you use other systems like hexadecimal, base 64 and such, which is a topic for another day. And you might not immediately see how arithmetic and all that can still be possible, even with 9 missing, because you're very much used to it being there. The first simplest thing I can do is show you a list of 2 sets of numbers. One is normal numbers in base 10, which we're used to, and another one is base 9 with the 9s removed. You pretty much just take out any number that has a 9 in it and keep it in the same order, and then according to their placement in the list, they correspond to the base 10 numbers. So unfortunately, this does mean there are a bunch of numbers which now mean very different things than what you're used to seeing. Now, base 9 does not have much practical use in anyone's daily life. But what if we keep taking numbers away? If we go down to base 8, base 7, base 6, let's go all the way down to base 2. These are binary numbers. If we start from 0 and we count up by 1, we can get to 1, and then we immediately have a problem because now we don't have a digit for 2. So we just go ahead and carry it over. Count up again. We have 1, 1. Carry that all over again to now have 1, 0, 0. And you might think it's a little cramped working this way, but this is a very valid number system. Again, not very practical for us humans, but it turns out actually very practical for computers. Wires in computers can have any kind of voltage between, say, 0 and 9 volts. We could have it be that each digit corresponds to a certain value of voltage, but for complicated reasons I'm not going to get into, it's much easier to design systems which only need to concern themselves with whether a wire is on or off. It especially helps when trying to transmit data faster in an unambiguous way. So in base 2, you have to memorize the powers of 2, which go from 1, 2, 4, 8, 16, 32, 64, 128, 256, and so on. Each number is double the one that comes before. That is no coincidence for base 2. For any one of these, you raise 2 to the power of n, where n is the number of steps to the left. To get the true value of any binary digit, you have to multiply it by the number associated with its position. By performing this multiplication for every bit and then adding them together, this is how you can translate binary numbers back into decimal numbers that we're more familiar with.
Nice.
Going back in the other direction is essentially asking, which of the powers of 2 do I need to use to add together to reach the same value in binary? And those numbers you use inform which bits are 1 in your binary number. I find it helpful to think of the largest power of 2 that can fit into the number that you're trying to convert. You subtract that from the number, write down a 1, and then you go down to the next power of 2, the smaller, and ask, can I subtract this from my working number? If not, you write down a 0, 0? If so, write down a 1. You repeat this process all the way down. And if you're working with computer science, I think that's enough to get you started. If you even need binary numbers at all anymore, you kind of don't. Anyway, you can follow these links if you want to learn more. Here's a playlist. It has presenters much better than I. Thanks for watching. If you enjoyed what I had to say, consider subscribing. If I got anything wrong, or if you have any suggestions for what I should do later, leave me a comment. And go and make your day a good day. You deserve it.